All right. The question is asking if you have, and it's about what we did yesterday. If you have a field goal kicker who has the ability to kick and make 87% of his free throws, all right, or not free throws, field goals, and he has kicked 3,000, what would we expect his percentage of made field goals would be around? Why? Alright, again, think about what we did yesterday.
It was a different question yesterday. Remember that there and I said 75%?
It was a different question yesterday. So think about this, Brother. We said, yesterday's question said Kobe Bryant has the ability to make 75 free throws, 75% of his free throws. Well, pay attention. Kobe Bryant, yesterday we flipped coins, right? And we found out that you guys all have 50% chances to flip a heads or tails. And we said that if we simulated, remember we even did it on the calculator. And we said, if you have a 50% chance at getting heads or tails, and you flip a coin 500 times, we expect that we're going to get how many heads? 250 because it's half, right? 50%. And then so, as Michael just said, we expect him to get 50% heads, 50% tails. And then we talked about Kobe Bryant. He makes 75% of his free throws. That's his ability. Okay? So 75% is his ability. So, and then we said he shoots thousands and thousands and thousands of free throws. And we said, anyone remember what we said about what we expect him to be shooting after those thousands of free throws? 75%. And we said we expected him to shoot 75% because the more times you perform, the closer your performance gets to your ability. So if this guy has an ability of 87%, and he kicks a lot of field goals, what do we expect his performance to be really close to? 87%. Right? Because he's performing a lot. His performance is getting closer and closer to his ability. Right? So I want you guys to take that, knowing that okay, he's going to make 87% of his free throws or field goals. That's his ability. I want you guys to explain why we expect his performance to be close to 87% after 3,000 field goals. And you also want to make sure that you have the explanation. Down there, we just her. She did that?
Yeah.
All right. So let's look at this. All right. So there's a couple things you need to take away from this. All right. Number one, we need to keep in mind that what we know is what do we know about the more times you perform, what does it get closer to? Your ability. So, the more times you perform an action, the closer your performance gets to your ability. So if we know this, if we all agree that 3,000 field goals, to kick 3,000 field goals is a lot of field goals? Yeah, that's a lot. That's probably taking like multiple. That's probably taking like 10 seasons if you're including practices and including games. You have to kick a lot of field goals to kick 3,000 field goals. So we all agree that's a lot. He performed a lot of times. What's this kicker's ability? So if we just stated that the more times you perform an action, the closer your performance gets to your ability, and we agree that 3,000 field goals is a whole bunch of field goals, what should his performance be after those 3,000 field goals? About 87%. So he should have made about 87% of his field goals. Okay? And that goes for anything. It could be whatever you like. If you spell the word supercalifragilisticexpialidocious correctly 63% of the time, and you have then spelled it, and you practice spelling it like 5,000 times, you should have spelled that about correct. You should have spelled supercalifragilisticexpialidocious correctly about, what did I say, 65% of the time, whatever I said. All right. I could do that, but that would take too much time. So we have in class. So again, this is an important thing to understand. You need to understand the more times you perform an action, the closer your performance gets to your ability. All right. Now, just to see if anyone remembers from yesterday, what did we say that your performance is equal to? Okay, everyone hear what Jamal said?
Yeah.
Jamal, say it a little bit louder. So performance is equal to your ability plus your random chance. Alright, so real quick, I'm going to do this. How many of you guys have your binders today?
I have mine yesterday.
You need to have it every day, including today. So what we're doing, as you leave class today, you need to show me your binder. Okay? If you don't have a binder, what you're going to do is you will walk here and get a binder. And if you don't have any, then that's your binder. I'm going to be nice today. Alright? After that, you need to have your binder every day because I'm going to start doing weekly binder checks now. I will not tell you when it's going to be. Okay? So, you'll take care of the binder checks after this. Now, what we're doing today, so a couple things. One, if you're looking at this, typically, okay, your homework is at the bottom of this page today. You guys are doing 1 through 8. You're taking this home with you. This is home. Okay, you will be taking this home with you. You're going to learn how to do your homework today. And you'll do 1 through 8 tonight and have it done tomorrow. For those of you that have a periodic binder, which all of you will, you should hole punch this put it in your binder, take your binder home with you, there's always going to be a whole bunch over there, and then bring it back with you tomorrow in pristine condition. That being said, we're going to take notes today. Several ways to take notes. If you have a notebook that has like holes punched, like a spiral notebook, you can take notes in that and keep that in your binder. Or you can use loose leaf paper, which I have up here if you don't have it. Again, guys, once this is gone, I'm not getting any more. Alright, so if you need loose leaf paper, there's loose leaf paper that you can use right here. We are taking notes. So, first things first. And what I'm going to do is I am going to turn out the lights because it has been making it easier for people to read this today. Alright, stay focused when you need, Caleb. Alright, I need you guys, okay, because we need to move through this. Yeah. So, first thing that we're going to be talking about today, alright, we're talking about in this part of the classes, we're going to talk about how to graph data. Alright? And you guys may have done this before, you probably have seen some of the graphing techniques we worked on. Now, first off, right here, eventually you'll get good at writing notes, and you'll know what to write. This stuff in the black is not necessarily 100% important that you write it down. The important thing that you need to get is this blue word, or the blue word down there that says variables will be broken up into two types. We will have categorical variables, and we will have numerical variables. Okay? Those are the two types of variables. So what we are doing is we are analyzing a lot of different athletic performances in different sports, whether it's baseball, basketball, golf, swimming, hockey. Okay, we are analyzing what happens in those sports. And those athletic performances, so the performances that we've been talking about, those are called variables. And those variables, again, are categorical variables and numerical variables. So if you're writing down anything on this page, it's the blue letters, the blue words that are important. So these variables, they may look like the number of passing yards for a quarterback or the outcome of a playoff game. Alright? So if you had to guess, because I'm going to give you the definition, if you had to guess, what do you think a categorical variable is? Yes, Charlene. Okay, something that's categorized. Alright? Like blue, red, yellow, then you're categorizing the color of shirts that people have. Alright? What about numerical variables? Charlene said something by numbers. So maybe time, right, or distance. And in this case, up here, so we have two examples up here. Number of passing yards for a quarterback. Would that be a categorical variable or a numerical variable? Numerical, why? Because passing yards are measured in numbers. Passing yards are measured in 350 passing yards in a game. It's not measured in completed in a game. That doesn't make sense. All right. What about outcome of a playoff game? Is that measured in categorical or numerical? Categorical. Why would it be categorical, and what would the two categories be? Think. Outcome of a game. You either win a game or lose a game. It's not a number. I didn't 3 a game. That doesn't make sense. Right? If I say, what was the outcome of that game? 3. 3 what? Alright? So it'd be 3 wins or 3 losses or 3 points. Alright? 3 points is probably more numerical, but the outcome of a game is typically you win or you lose. Or in some sports like soccer, you can tie. You know, you can tie in football too. NFL, not college. Now, questions about that. So I'm going to give you the actual definitions and some more examples now that I want you to write down. So this next page, you're going to want to write down everything. All right? You can look for ways to shorten stuff. So categorical variables. So you can put outcomes fall into categories. You guys just said that yourselves. All right? Examples of categorical variables. We just also talked about outcome of a game is wins or losses. In basketball, you either make the shot or miss the shot. There's no like in between. You can't like make and miss the shot at the same time. That wouldn't work. In baseball, when you're batting, you either get a hit, you get out, or you walk. All right? There's nothing really in between unless you get technical and talk like about a balk or something, which I don't even know what that is.
Oh, I can tell you.
You can figure that out later. Too much baseball.
It's fainting. The pitcher is fainting.
So I think what it is,
It's cheating.
thanks and like acting about the pitch the ball in the home plate, but then it's not.
Left-handers are cheaters.
That's
They're all cheaters.
numerical variables. All right. The possible outcomes are a number. And you can't see that one down there. It says the distance a golf ball travels, or another example would be the time it takes to swim 100 meters, or the time it takes to run 100 meters. I'm sure we have some track people in here, right? All right, so the time needed to swim 100 meters, or run 100 meters. Okay? So if you think about it, that makes sense. Time is measured in number of seconds, number of minutes, number of hours. Distance is measured in a number. You can't just say, I traveled yards. How many yards did you travel? All right?
Wow.
So numerical variables are going to be things that are measured in numbers. All right? You guys give me an idea of where we are in writing right now. What part of this are we at? How many of us have done? Again, I will say the examples that I have up there would probably help you on your homework. All right, there are going to be, I know it's probably a little funny. It copied good the first one I made. I think it might be because I copied a copy. So do your best. I'll make sure that copy's better from now on. All right. So how many of us are just about done? Again, the examples will help you on your homework. Yeah.
Can you go down?
Go down. This is the last thing right here. All right. Yeah, one wall. Questions so far in categorical and numerical. Here's an example that I want you guys to tell me. The average time a player spends in the penalty box in hockey, what would that be, categorical or numerical? No. Numerical. It's probably a safe bet. If we're talking about time, it's going to be numerical. All right. What about this? The record of the Chicago Bulls when they won 72 games and lost whatever. That would be categorical. It's a record. Typically, records are going to be categorical because win, loss, tie, whatever. All right. You have a few more people finishing up writing? So what we're going to talk about now is, okay, we know how to categorize this, okay, that's great. But how do we look at this? Like, we have all the numbers. How can we organize this in graphs and look at this and draw conclusions? Okay? So what we're going to talk about, there is going to be 3 types of graphs. On this next page, there's a bunch of words. You don't necessarily need to write them down. All right? So what we're gonna talk about now is, am I good to go? 5, 4, 3, 2, 1. Remember, if you don't get them all down, you can always go back and watch the notes and fast forward and see what you missed. So, generally the first step that you guys are going to want to do when you're about to analyze something in this class is you're going to want to create a graph. 3 types of different graphs that we're going to talk about. Anyone want to try and guess any of them? You guys have seen, huh? Not a line graph. That's like the one graph that, bar graph, pie graph, we'll call it, we're calling charts. Alright, so pie chart, bar graph, they all the same words. And then there's another one that we're going to talk about called a segmented bar graph, which you may or may not have seen. Alright, so what we're going to do is we're going to learn how to take these and sort of just create a graph that represents the distribution of these variables. And the distribution right here, that's just how the distribution is a fancy math word of how we identify the different categories of the variable and the number or percentage of observations in each category. All right, so it's just a fancy word of how is the data divided up. Okay. Again, you're not going to be tested on like what's the definition of distribution. Okay. So that being said, the first graph we're going to look at is pie chart. Okay. I can see that back to the beginning. Pie charts. There's 3 important things to make sure you do. 1, and this isn't just for pie charts, it's almost for like bar charts as well, but you want to label each chart in each category. Label, label, label. I will take points off on tests and quizzes if you don't label. Okay? So, if you're looking at these 2 charts right here real quick, you notice they label them miss, miss, made, made. We know this chart is regular season. We know this chart is playoff. It's labeled. We know that both of these are talking about the 3-point shooting performance for LeBron James. I don't think I just care about LeBron James. I don't. It's easy to make a copy of what's in the book. All right. We can look at any basketball player, or any football player, or any athlete. We can look at even stuff outside of sports. We can look at stock performance and different things like that. All right. Another thing you want to make sure that you do is use consistent colors. Notice, missed are both colored orange. Made are both colored some ugly yellow. All right. What could be challenging if I decide to flip the colors over here and make made orange and missed yellow? What might happen when someone looks at your chart? What? They might get mixed up. What do you mean? Exactly. Right? If you change the colors just randomly, they might start thinking, well, dang, he missed only 25% and made 75%. At that point, some of them think you're crazy if you say that he did worse in the playoffs. All right? Because I'll tell you this. A lot of people, if you just have a display up there with graphs, they expect everything to be like that. It's different than they're going to not know what the heck you're talking about. And then finally, the last thing you want to make sure you do is this is like everything. You want to make sure pie charts are the same size. You don't want to have one pie chart be this size and then another pie chart be the size that I drew over here where it's huge. Because it's not the same proportion. Alright? The proportion, this one looks, it's bigger, so people are going to assume that it's more. Alright? Whenever you're graphing things and you're drawing bars or pie charts, you want to make sure that you have everything at the same proportion. All right, you guys are going to get practice on that on 4 parts of your homework tonight. Okay? drawing these two pie charts down because you guys know what pie charts look like, I think. If this is the first time you ever seen a pie chart, you might want to drive down. But if you've seen pie charts before, and if I showed you a picture of a pie chart and a bar chart, you can tell which one the pie chart is. I don't need to draw it down. Alright? Now, the next two we're going to talk about, segmented bar chart and bar chart. You may want to just draw like a quick sketch down because they sound the same, but they're a little bit different. Alright? So, 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. I think most of the time we just not doing they might be good about this up on the mouse. Start doing the stupid thing. Alright, bar charts. There's two types of them. Okay, yeah. Okay. The stuff in the black right here says almost the same thing as the stuff that you just wrote down in the pie charts. So if you want to just write two types, segmented bar chart versus bar chart, and then draw like a quick sketch of what the pictures look like so you know the difference, that's fine. And then just know that you want to say like maybe same things as pie chart, right? So you have two types. Segmented bar charts are where the bars are on top of each other. They aren't side by side. So notice, instead of putting regular season makes and misses apart from each other, they put the regular season together and the postseason together. All right? And typically when you're dealing with this, you're going to be using percents. So in the regular season, all right, you'll notice that, okay, the percents and the numbers over here go up to 100. Why? Because when you add up all his makes and misses, that's 100% of it. That's 100% of all the shots. All right? Same thing here. So a couple things you want to make sure that you have on this is you want to make sure your percents always add up to 100. All right? You also want to make sure that your axes are the same. Notice it counts 0, 20, 40, 60. It doesn't go 0, 10, 50, 60, 90. It counts by the same amount every time. That's important when you're making these. All right? I'm going to open up the door a little bit so that we can try to get some cool breeze in the hole. Alright, and then over here, this is the standard bar chart you guys know. I'm sure you guys have all seen the bar chart where they're side by side. Alright, you can organize them however you want, but we want to compare makes and misses. Alright, so we want to compare makes and misses and misses. So over here, it's easy to compare 31.5 to 25.7. It's easy to see, okay, he shot a little bit worse. Over here, it's easy to see, okay, he made a few more of his shots in the regular season playoffs. Alright? Again, everything is labeled. When you guys make your graphs tonight on your homework, you want to make sure you put the percents in there. Alright? You want to make sure you label the axis. Questions about the difference between a segmented bar graph and a bar graph. One other difference over here is a bar graph. Notice it only goes up to 80. Does anyone know why it goes up to 80 instead of 100? It's a percentage. Okay, good. So in this one, this is the regular season. You have to represent 100% of his shots right here. So this one goes up to 31.5 on the axis because that's 31.5% makes. And then you have to add on the other 68.5 and get up to 100 for the rest of the shots. Over here, you're just, what is it? Over here, instead of it being by season or by part of the season, it's by makes and misses. This only has to go up to 31.5. So if we were just doing makes, which you'll see in just a second, this axis wouldn't go higher than like 35. But since this goes all the way to 74, we need to go at least up to 74%. So we have 80% just because it's a nice number. All right. So it's all based on whether or not, in this case, they divided it up based on part of the season. Over here, they divided it up based on makes or misses. All right. We have one last thing to talk about. This is going to help you on your homework. You need to write down what's in the green. So when does anyone need to have that be a little bit bigger? So what it says, and this is important, when comparing distributions, it is very important that the percentage or proportion of observations in each category be displayed rather than the number of observations in each category. So the graphs are easy to compare. So what this is saying is when you make your graphs, you want to make everything be in percent. You don't want to put, oh, he hit 54 home runs and had 543 at bats. You want to say, what percent did he hit home runs? All right? So you want to get all of your data into percents. And we're going to talk real quickly about how to make sure you get stuff into percents. All right? So if you're in the process of writing out all that and you want a little bit shorter version, a nice way to put it would be use percents or proportions for data instead of numbers. Yes, percents are numbers, but so you want to put like use percents or proportions of observations rather than number of observations. Use percentage or proportion of observations rather than number of observations. One last time, use percentages or proportions of observations instead of numbers of observations. So don't do how many times did he hit a home run, do what percent of the time did he hit a home run. Don't do how many makes did he make or how many makes did he have, do what percent of his shots did he make. Don't do the number of minutes that he was on the time, do percent of the minutes that he was on the time. Or on the ice. Instead of number of observations. So for example, when you're looking at this, if I ask you just to look at this, and if you compared, if I asked you to compare if I asked you to compare like his performance in regular season, which is in the blue, and postseason, which is in the red, and that's all I gave you, what would you say about that? So he had 113 makes versus 18 makes. Did he do like? How does that compare to the regular season when he had 246 misses and 52 misses? So Caleb says he shot more in the regular season than he did in the playoffs, which is what you need to take away from this. All right. A lot of times what people would see is, well, he made a lot less threes, so this makes it look like he shot horribly, like horribly. Like, there's no way he wasn't even close to his regular season percentage. All right? Because look how small this little bar is compared to this graph. It makes it look like he shot very, very bad. Same here, it makes it look like he just missed. It makes it, right here, it makes it look like he didn't miss much. He only missed 52 in the playoffs. But he missed 246 in the regular season. That kind of makes it look like he shot better in the playoffs. He missed a lot less, right? But what do you have to take into consideration? Why did he shoot so many less in the playoffs? No, think about how long the regular season is versus how long the playoffs are. 82 games in the regular season, like Michael just said, and at most 28 games in the postseason. All right. Whereas over here, by using the percentages, did he shoot worse? Yes, but it isn't that much worse. Look how close the percentages are. All right. Same here. All right. He didn't miss much more in the regular season. It's a few percentages more, but yeah, it's not like it doesn't look like this bad. All right. Finally, I just want to go over one review type of thing that I need to make sure you guys understand for your homework. How do you find percentages? Right? So if I know that LeBron James in this example, okay, he made 31.5 of his shots. But how do I find out? Not times. We're dividing some to get to the percentage. So right here we're finding percent made. Now what are we dividing when we find percent made? 100. All right, so Jamal, what are you gonna say? Okay, so Jamal said you divide the makes by the misses. I agree with part of that. All right. Okay, so you can divide number of shots made divided by number of shots taken. All right. So in this example, you would have 113 made shots in the regular season, and you would divide that by what? How many shots did you take? Okay, so you have to be careful. A lot of times, you might want to say 113 divided by 246. Did he take 246 shots, or did he miss 246 shots? He missed. So the total, yes, you have to add the makes and the misses, which is 359, I believe. So then you divide 113 by 359, and you get 31.5. All right. So now the reason I say that because on your homework, problems 4, 5, 6, and 7, you have to make these graphs yourself. Okay. So I need you to do your best on problem 3, 4, 5, and 6. So what you're going to do, like for instance, if you look at number 4, all right, number 4 says that this goalie, Patrick Waugh, he saved 25,807 shots. Okay, that's way off. And that's number 4. And then he faced, so people shot the hockey puck at him 28,353 times. All right. So to find the percentage that he saved, you would do the number of shots that he saved divided by the total number of shots he faced. So you divide that. This is 0. It's 8 0. On your homework. I know it's because this cardboard got all messed up real quick. Alright, so it's 25,807 divided by 28,353, which would give us it would give us 25807 divided by
91.
353, so 91. So that'd be about 91%. Wow. This number's about 91%. I don't know what that is. %. Well, that's not the answer. So what you have to do is you have to take that information. He saved 91%. So if he saved 91%, what percent did he not save? 9%. Because it has to pull up 100%. Are we listening? So you have to make a graph where, all right, so you label your axes and whatnot. All right? So you have to say, okay, during the regular season, which I believe this is, he saved like 91%. So let's just say the top is 100, so it's a little off. And then, how many did he not save? He didn't save 9%. So you put didn't save, so you put 9% over here. And then you have to do post-season as well.
For the lunch period now, all 3 month period attendance, please enter that now. Thank you.
You understand what I got to do with the graphs on homework? So then in the postseason, if you're looking at that, since most of us have already put it away, those of you that still have it out, it says that he saved this number of shots. He faced this number of shots, 65. And how many did he face? All right, so you divide those. That comes out to about 91.8%. All right, so this is going to be almost identical. So this is saved, and you have to label them, and then about 9%. This is scored on, and you have to label your axes. So you would say like percent saved or percent. You just have to know that this is a percent, and you label those, and then you're done. Your graph better look better than that. We'll do numbers each. Alright, but that's what you're doing for those, and then numbers 7 and 8 are just your opinion. You just have to explain your opinion. Numbers 1 and 2 are just based about categorical numerical data. Okay? Questions about that? No. Huh? How do you get the percent? Oh, change back that slide. This is just for this one. All you're doing, like in all of them, it says one of them says like home runs and at bats. You just divide home runs and bats. So you divide 54 divided by whatever the at bats were. That's going to give you a percentage. All right. 2 of them ask you to make a bar chart. 2 of them ask you to make a segmented bar chart. So the only last thing I'm going to ask you guys is how to do it.